Hey everybody, just wanted to put together a real quick video for those of you who are still kind of figuring out where to get started on this project. So basically in this project, you're building your own priority queue. And it's a little different than the one from lecture 20. Now I'm not going to say anything at all about heaps and priority queues because there's a whole other lecture video about that. So if you don't really know what they are, like if you don't know what syncing is, swimming is, all that, you have to go watch that video first. If you don't do that, you're never going to be able to get started. So at any rate, you're going to build a priority queue. It's a little different than the one in class. Specifically, the main difference is that when you add an item, you also assign its priority as part of the add operation, which you'll notice is quite different than what we did in lecture. There's also a change priority operation that lets you change the priority of an item, and I guess one of the second order effects of that definition is that our priority queue, it does not allow multiple copies of the same item. That is, if I add an item and then I try and add it again, then you should throw an illegal argument exception. Okay, and I added a note here that you can assume the item is never null, which will save you some trouble. So that's the whole project, basically. Build this. So what we give you is a naive implementation, and you don't have to understand how it works. It's just some code. It's just there so that you know it's something you can play around with and get a sense of how it works. The only thing about this is that it does not throw the right exception. So it should check to see if the priority queue already contains the item. Here, I don't. And the reason is otherwise it's too slow to use, okay, for your own testing purposes. But we give you basically an implementation. We also give you, and this is new, a class that will print out a heap. So one of the TAs was saying it's kind of hard to debug without a way to visualize your heap. So I've given you two print methods that you can use to print out a heap. This is the simple version of a heap. This is the more complicated one. You're welcome to copy and paste this code into your own if you'd like. And this code assumes that the array you're giving it is a heap, and that's that. The other thing that we provide is timing test demo, which gives you an example of how you can run tests that determine how fast your code is. So on my computer, it runs these two loops in 0.6 seconds. And there's two different ways of doing it. The first uses something called system.currentTimeMillisecond. The other one uses a stopwatch class. So you might find that helpful if you want to time your code. Okay. So those are the things we give you. Now, in terms of what you're actually building, you're building an array heap min PQ. This is very similar to what we did in lecture. So you have to have an instance variable that is a min heap. That is, it is a collection of items that obey all those min heap properties. And you need to represent it either as an array or an array list, your choice. If you want to kind of pattern match from the lecture or from the example code that we point you to, use an array. But an array list might save you some work, although the code's uglier, in my opinion. You're not allowed to import weird stuff. You can only import specifically from java.util or org.junit. And very importantly, and this is one of the things that makes it tricky, is that your get smallest, contains, size, and change priority methods, they have to take login time and no more. Okay. Now your add and remove smallest must also be big O of login, but they only need to be login on average. That is, since add and remove smallest are going to be operating on an array, those arrays have to resize occasionally. So it can't be big O of n because add and remove smallest will resize an array. So it just needs to be on average login. In other words, it should look like login except for resizes. Okay. And just one note is that if you are resizing an array, make sure to use a multiplicative factor. That is, multiply your array size by 2 or whatever. Don't add 100. Now, if you're using an array list, you don't have to think about that because the array resizing is all done below the level of abstraction. But that's just if you're using an array list. And we say don't waste memory. So if you're using an array, make sure to resize down too. Okay, so that's the basic picture. Now, of course, one of the big tricks with this project is that you don't get an autograder. I mean, you get a very basic set of sanity checks, but you're gonna have to write your own tests. And that's part of what the project's all about. And it will make the project harder, right? I mean, the basic project, it's not so bad. The only new challenge, really, that's not in the lecture is how do you write change priority so that it's efficient? Everything else is almost straight out of lecture in certain ways. I mean, you've got to do some thinking, but it's not like a gigantic leap compared to, say, homework 2, where you had to do that, virtual node stuff at the top and the bottom and percolates and all that. Like, the cleverness in this project is much less, but we're making you guarantee that it is correct. So we have a bunch of tips about how you can write tests. I will kind of just very quickly go over them. So you should put your tests in array heap min pq test. And you're going to learn a lot about testing just doing this. Like, I think me just reading off this list will be a little boring, but I'll go through kind of the most important points. So first, I guess I would say that in general, I would recommend that you write tests that verify the behavior of your priority queue based on operations that return output, like get smallest and remove smallest. That is different than tests that look at the instance variables of your array heap min pq. You can do that, but I think this approach is just a little nicer. Now, that of course means that there are some operations, like say add, that you can't just test on their own with this approach because add doesn't produce output. So if you want to, you can write tests that look inside your instance variables, but if you do that, you'll need to put them in the array heap min pq class itself. That is, you can't put it in array heap min pq test because these variables should be private. Okay. I would recommend that you write a test for functions in the order that you write them, and that can include, if you'd like, private helper methods. Now, one pretty annoying thing is, let's say you have a left child method in your array heap min pq class. Well, you can't test it in array heap min pq test. So you would either need to put the test in the array heap min pq class itself, that is not the test version, or you're welcome to make your helper methods what is called package private, and that just means not putting public, not putting private, and that's a third type of access modifier that we haven't talked about in class. So it's in between public and private. When you're writing tests, you should consider your edge cases whenever you're thinking about what are the things you need to cover. But alternately, you can also try and compare the outputs of your data structure with the provided naive min pq. Now, one potential issue there is that if items have the same priority, you have to break ties arbitrarily, so randomized testing will be kind of tricky to cover that corner case. So you can just not test that corner case for randomized testing and write a manual test. Or there are ways around it, but I won't talk about them right here because it's a little bit kludgy. And then lastly, you should actually test the runtime of your code. However, what you don't need to do is try and fit some curve and say, is this logarithmic or whatever. You should just make sure that your code is a heck of a lot faster than the naive version, and we give some rough picture of what that means above. Now, one quick note here is that when you write timing tests, make sure that you're using a fixed number of operations on a growing data structure. So for example, if you were to write a timing test that iterates over a priority queue of size 100,000, and it actually calls contains on all of those, and you did that for a size 100,000, a size 1,000,000, a size 10,000,000, what you would see is that the runtime is increasing linearly, even if the contains method is constant time, simply because you're making a growing number of calls. It's a subtle issue, maybe doesn't make any sense now, but when you're writing timing tests, hopefully that triggers something in your brain as you're considering tests. And so lastly, in terms of the external resources we provide, so you're welcome to go looking online at other priority queue implementations. Of course, you should not go looking for specific answers to this project, but anything you do find out there, please use the source tag. And you're actually welcome to look at the priority queue implementation in the Java textbook, in algorithms textbook. I think that's a great exercise, partially because this project is about building a different priority queue than this one, and trying to figure out how to translate information in this into your implementation, I think is a great exercise. I mean, it's the kind of thing you'll do always, right? Where you go out looking on the web for something similar and you need to adapt it to your purposes. So you're absolutely welcome to and encouraged to look at this file. What I don't recommend doing is trying to copy and paste big chunks of code into yours and saying okay, I'm gonna put it here and then try and make it work. That's just not a good approach. You should do things, if you take pieces or ideas, you should do them a little bit at a time and just very carefully think about what you need, right? And it'll take time. I mean, this project is not intended to be something that you just sit down and crank out really fast. It'll require some thought. And the testing part in particular will make it a little trickier. Okay, so I think that's all I really wanted to say in this little video. I hope that was helpful. Yeah, let me know what you think. See you soon.